Eggs on him. We gonna make eggs and ham out of Moses, yeah. Let's get it.
We had to figure out when to drop an egg from 25 feet in the air in order to hit our physics teacher on the head as he walked beneath. And just like that, our physics class is cooler than yours. To come up with the solution, we had to solve for some unknowns in our equation. Isaac's gonna take that away.
Okay, so to explain the math we did to solve for when we should drop the egg, you have to split up into two parts. The first part is Moses walking, and the second part is the egg drop. I'm actually going to explain the second part first, but Moses' walking is easier to solve for. But for the egg drop, what you have to do is you have to take the height that we dropped the egg from, which is 29 feet, because it's off a 25-foot platform plus my arm, which is exactly 4 feet above where the platform is when it's reached straight out in front of me. And then you have to subtract 6.46 feet from that, because that's how tall the top of Moses' head is, so that's where we want the egg to hit him. So when you take 29 feet and you convert that into meters, it's 8.84 meters, and Moses is 1.97 meters tall, so you do that subtraction, and it's you figure out what you're trying to solve for. The t you're trying to solve for is how long it takes an egg to free fall 6.87 meters. So what you plug into the equation, there's a few numbers you plug into the equation, and you're going to use the equation y, which is position equals initial position y0 plus initial velocity v0 t plus 1/2 at squared. So when you plug in numbers for that, it ends up as 1.97, which is the height of Moses, equals 8.84, which is the height that we dropped the egg from. Again, these are in meters, plus 0t, because the initial velocity is 0, plus 1/2 negative 9.8, because acceleration is, in this scenario, is negative 9.8 meters a second squared, and then multiplied by t squared. And the t is what you're solving for, so when you solve that out, you end up with negative 6.87 equals 4.9 t squared, which then, when you do some algebra, it turns into t squared equals 1.402 seconds, so t equals 1.184 seconds. So what that tells you is that we need to drop the egg. We needed to drop the egg when Moses was 1.184 seconds from straight below where the egg would be. So we had to figure out how much Moses would go in 1.184 seconds. So that goes back to the first part of the equation, the easy part to solve for, which is once you know that number, you can multiply 1.184 times Moses' walking speed, which we calculated was 1.33 meters a second. And when you multiply 1.33 times 1.184, you get 1.574 meters, which is how far Moses should be from straight below the egg when we drop it. So we decided that from that we would make a mark at 1.574 meters from straight below where my arm was reached out, and that is the math.
Knowing our final value, we headed outside the next day. On the day of the drop, we chose a crack in the pavement as our base position. Using the same method as Isaac described earlier, we measured out 1.574 meters away from the base position. When our physics teacher was on the mark, I would have to call up to Isaac in order for him to drop the egg. It definitely wasn't a perfect system, but it was what we had to work with, and we could make it work for the trials. The very first group to go hit our teacher on the shoulder, the next one the chest. We were determined to be the very first group to hit him straight on the head.
Oh man.
We hit him on the hand. Close enough. Needless to say, either our math was off slightly, or I called out Moses' position a little bit too early. We may have had to account for more values that we didn't find immediately present in our experiment, such as wind speed, direction, and reaction time. We did have some questions to further our exploration of free fall, such as how the distance we would have to let go of an egg would change if Moses had had a constant, positive acceleration. What would happen if we dropped the egg from 100 feet, or even higher? Would we have to account for wind speed and direction then, as the egg would be falling more and traveling faster when it hit the ground? Is there any way we can play archery or darts with eggs while holding them 25 feet in the air? We may not have found the answers for these questions in this experiment, but further experimentation may yield some results.